Hey guys, today we're going to look at describing functions. So describing functions means that we're going to have to look at a lot of different words that we use for things. So what I would like you to do right now is pause and try to think of as many different words for x-intercepts as you can think of. All right, so some of the words of x-intercepts that you might have thought of. You might have thought of the word zeros. That's one word they use for x-intercept. Sometimes they call those solutions. The solutions to an equation, those are going to be your x-intercepts. Sometimes you'll see them called roots. All of those things are x-intercepts. Now there's several different ways to describe points as well. So the most common way to describe a point is at a coordinate, as a coordinate, right? X comma y. Another way that they'll describe it is they'll put f of some number equals some other number. Well, remember f of means f of x, so that's my x value, and then whatever my f of x is equal to is my y. So that's how we get that coordinate, xy. We'll also have very specific points when we talk about x or y intercepts. We might also mention an extreme. Maybe there's an absolute max, absolute min, something like that. Okay, so here's what we know about even and odd functions. And in fact, let me go ahead and scribble this out because I actually did not put that correct. And I'm sorry about that. Here's what we know. With even functions, when we plug in the opposite of x, we end up with the same function. So here's what that means. Down here we have a function that passes through 2, -2, and 4, 8. So if I plug in the opposite of x, I'm still going to get the same y out. So if I'm passing through the point 2, -2, and it's even, that means I can put in the opposite of x. The opposite of +2 is -2, and I'll be left with the same y, also -2. Okay, so we also have this point 4, 8, right? And we're going to say that this guy is even. If he's even, that means that we have the point -4. Remember, I can take the opposite of my x, and my y stays the same. So that will be 8. All right, with odd functions, we knew that when we plugged in the opposite of x, we got the opposite of the function, right? So now when I plug in the opposite of x, I'll get the opposite of y. So if I have a point on my graph that's at 2, -2, and my function is odd, I'm going to take the opposite of my x, and then my y is going to be opposite as well since it's odd. Okay? All right, now let's look at that 4, 8. So we had to take the opposite of our x, so that's -4. Now since it's an odd function, that's going to turn my y opposite as well. So it'll be -4, -8. Good deal. All right, so if a function passes through -8, 3, and -4, -2, give two other points that are on that graph if it's even and odd. So with even, it's going to be opposite stays the same. X is opposite. Y stays the same. So we'd have +8, 3, and +4, 2. If it's odd, we're going to take the opposite of our x, so it'll be +8, and the opposite of our y, so -3. Opposite of our x, so +4, and opposite of our y, so +2. Okay, So you are going to be told to graph a function described, and it can be a little bit overwhelming when it's just all this information and then go. Here's what I would have you do. First of all, go through and remember how we talked about there's a bunch of different ways to describe points and x-intercepts and things like that. Go through and write out each coordinate that you know actually falls on that graph and plot any of those points. Look at end behavior to see if you have any asymptotes. So if you remember, we would have asymptotes. Asymptotes are that line where your function approaches but it never touches. So if your end behavior is going towards a number on a certain side, that means that we have an asymptote at that number. So graphing asymptotes, look at your end behavior when you're approaching a number. Okay, then draw the ends of the graph. So look at the end behavior again. Maybe it's going to positive infinity, maybe we're going to negative infinity. It's going to kind of show us what's going on. Then we're going to connect all of our dots in our graph and just double check that each time we're drawing a piece of our graph in that it's making each of those specifications from the description true. And remember that it doesn't have to be perfect. We're going to try our best. As long as it has all of those features that we talked about, you did a great job. Just try your best. Everything will be fine. Okay, so we want to graph the function described. Okay, so it tells me f of 3 is 1. So here's what that's saying to me. When x is 3, y is 1. And what that tells me is that I have a point at 3, 1. I have a 0 at -4. That means I have an x-intercept at -4. So that means I have a point at -4, 0. F is decreasing for when x is less than 0, and f is increasing for when x is greater than 0, but I can't really do anything with that right now. It's going to say that I have a solution at 2. A solution is an x-intercept. So that means that I have a point at 2, 0. I have a y-intercept at -3. So that means I have a point at 0, -3. And then it says, as x approaches positive infinity, my function approaches 2. When I have my end behavior like this and it's approaching a number, that means I'm going to have an asymptote at y equals 2. We'll deal with that in just a minute. And then as x approaches negative infinity, f approaches positive infinity. We'll take care of that in a minute. So we already have 4 points to plot. Let's plot those. So we have a point at 3, 1. And we have a point at -4, 0. And we have a point at 2, 0. And we have a point at 0, -3, right? Then it said that we had as x approaches positive infinity, my function approaches 2. So over on my right side, where x actually does approach positive infinity, I have an asymptote at y equals 2. So at least on this end, my graph is going to get closer and closer and closer to that asymptote. Now, I went ahead and graphed just from 0 on, and I'm going to check out, it says f is increasing for x is greater than 0. Is my graph increasing after 0? Yeah, absolutely it is. So then we'll connect our dots over here. All right, so is x decreasing for when it's less than 0? Absolutely. And then as x goes to negative infinity, does y go to positive infinity? Yes, it does. So we graphed it correctly. Go ahead and try graphing this guy. The only thing that I also want to throw in here is that there is an absolute max at, I'm sorry about this, 3, 5. With all of those things, and there's also an absolute max at 3, 5. Go. Okay, so on this one, we should have passed through 3, 5, 6, -1, -1, 0, 5, 0, and 0, 2.5. And our graph should look something like this. All right, have a good day.